Hi everyone, we want to today learn the wildfire burn area detection using the Sentinel tool. The wildfire leaves behind the visible signature on a vegetation and soil that can be detected using the satellite remote sensing. And one of the most effective spectral indices for assessing fire damage is normalized burn ratio or NBR. And NBR used to difference between the near infrared and short wave infrared bands, and we use here the pre-fire NBR and post-fire NBR. The difference between the two dNBR highlights effective by fire, and we use some threshold method for this, and we implement this for Los Angeles, California, detect burned area from wildfire between January until February 2025, and data source is the Sentinel-2 level 2A harmonized, and output will be pre and post fire RGB composite, dNBR, and burned area mask. First of all, we need to define the area of a study with a bounding box. If you know how can create a bounding box, you can watch the video of this. And we need to define the before the fire and after the fire with a variable like this, and we need to write the code to uh, masking the cloud. We use the QA16 algorithm for this, and in this algorithm we need to define the cloud bit mask with this formula, and serious bit masks with this formula, and we define the mask variable of a mask for clearing this image, and after this we can load the collection of a Sentinel-2 satellite. We use it S2 harmonized, and if you don't know what is S2 harmonized, you can watch the video related to the tool color of a Sentinel-2, and we filter the bond based on area of interest, and we use it there the cloud percentage of 5. And after this we need to create the median composite because we need to create the mosaics and find all images in the area of interest for the pre-fire and post-fire. And after these steps we compute the NBR. We use this normalized difference P8 and P12, and we name it NBR, and we define this function, and we use it for the pre-NBR and post-NBR, and calculate the dNBR with the pre-NBR dot subtract to post-NBR, and we rename this to the dNBR, and mask the burned area like this with a dNBR dot greater than 0 point dot self masked. And the final step is a add layer on a map, pre-fire two color image, post-fire, and dNBR and burned area detected. We can change this value to better visualization. If I run the code, you can see in Los Angeles area we have a 4-layer pre-fire RGB, post-fire RGB. We need to wait to load this data. You can see visually we can detect the some changes here, but if we had to calculate dNBR, you can see with the dNBR we can easily detect this area, and with the burned area we can detect the burned area, and we can overlay on the map like this. It's north of Los Angeles and west of Los Angeles. This area burned on January 2025. Application of this code are wildfire damage assessment, post-fire recovery monitoring, forest fire and forest and land management, and insurance and disaster response. Thank you for your watching. Please like and subscribe our channels.